All right, example 10. We've got a trig function. We're on the interval 0 to 2 pi. The first thing we're going to look to do here is take our first derivative. The derivative of cosine goes to negative sine, so I should have plus 2 sine 2x. I need to do my chain rule there, so times 2. All right, now we run into a little bit of pickle with this sine of 2x. We're going to be trying to set this equal to 0, and that's going to cause some issues for us to solve. So over here to the right, I do have a handy-dandy unit circle. We're going to get into plugging these values in, and I'm going to use that as a bit of a reference. But I do also want to show you these double angle formulas. So these double angle formulas, we did run into pre-calc very briefly last year. The one that we're going to need for this proof or this problem is 2 sine of x cosine of x. Now there are some really handy double angle formulas are actually going to be these cosine ones, and you may want to make a note of those. Those come in handy a little bit later in the course, but cosine of 2x will go to cosine squared of x minus sine squared of x. And then there's a couple other forms, and we get these forms from applying Pythag. Okay, but the one for right now is this sine of 2x is 2 times sine of x times cosine x. So I can rewrite my g prime of x that I'm going to be setting equal to 0 as 2 cosine x plus 2 times, this would be 2 sine x cosine x. And since I'm going to be setting this equal to 0, what I can look to do is undistribute common things, which is in both terms I've got a 2 cosine x. So I'll take that out and I'll be left with 1 plus, this would be 2 sine x. Now, I'm going to take these terms, and each one I'm going to set equal to 0 individually. Cosine of x is 2 cosine x is equal to 0, and we'll do that one first. So what I am effectively looking for here is where cosine of x is equal to 0. So cosine of x being equal to 0, I'm going to draw my little circle, and cosine, remember, goes with the x, so I need it to intersect with the x value is equal to 0. So I've got this vertical line here, and I see it's going to be these 2 points. And maybe you remember that these 2 points would be pi halves and 3 pi halves. Remember, we are trying to keep these values in between 0 and 2 pi. That one is easy enough. So far our critical numbers that we've got, x is equal to, we'll put pi halves and 3 pi halves. All right, now we want to do this 1 plus 2 sine of x term, and we're going to set that equal to 0. And when I do that, I'm eventually going to get sine of x is equal to negative 1/2. Again, I'm going to draw this little circle. And we need to keep in mind here that in this case, we're going to be setting this equal, because sine goes with the y, to y is equal to negative 1/2. So going across, I need where y is going to intersect. Now, you may or may not remember these. I'm going to scroll over here. Notice that sine has a value of negative 1/2 at 7 pi sixth and 11 pi sixth. And so I will add those in here. I'm going to have 7 pi sixth and 11 pi sixth. The next bit that we're going to go into is testing all of these numbers. So first I'm going to do f of 0, that's my first endpoint, and then I'm going to do f of pi halves, followed by f of 7 pi sixth, f of 3 pi halves, and f of 11 pi sixth, and lastly f of 2 pi. And, oh, and I wrote all those as f's, so I should have wrote them as g's. So I've got g of 0, g, 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 g. Okay, so g of 0 here would just go to -1. G of pi halves, that's going to go to 2 plus 1 is equal to 3. For 7 pi 6, I'm going to get 2 times -1/2 minus 1/2 is equal to -3/2. For 3 pi halves, again, I'm going to get, well, similarly, I'm going to get -2 plus 1, which is -1. For my 11 pi 6, I'm going to get 2 times -1/2, oops, minus 1/2. Again, that's -3/2. And lastly, for my g of 2 pi, I'm going to get -1. Okay, if you had any issue with those, of putting those together, you may want to reference a unit circle like this. For those, there is going to be a little bit of a trick. This is cosine of 2x. So I'm going to show a little bit more detail. I'm going to do it with this 7 pi 6 example of what me finding those numbers looks like. So if I did this g of 7 pi 6th, okay, I'm going to have 2 sine of 7 pi 6th minus cosine of 2 times 7 pi 6 is going to go to 7 pi thirds. All right. So now I need the sine of 7 pi 6. So the sine of 7 pi 6, I'm going to kind of clean up this. The sine of 7 pi 6 is going to be the associated y value. So I'm going to get 2 times -1/2. And then I need the cosine value at 7 pi thirds. Now I don't have a 7 pi thirds on this unit circle. I get to 5 pi thirds. The next pi thirds, my 7 pi thirds, is going to be the same as this pi thirds. So my cosine value here is 1/2. So I'm going to get -1/2, and that leads to my -3/2. So that's an example of what those calculations look like. Okay, so pulling all this together, our max of g is at pi halves. It's this 3 value, and our minimum of g is going to be at 7 pi 6, and at 11 pi 6, this -3/2 value. All right, you made it through number 10.